the Doppler effect, you know, the frequency-related phenomenon that is explaining the change in frequency due to the relative motion between the sound source and the listener. If the sound source is coming closer, the pitch increases, the frequency gets higher. If the sound source is moving away, the pitch decreases, the frequency gets lower, like the ambulance passing by. Woo! It is usually explained by frequency, while actually it is more somehow a phase-related issue. Why and how could we describe Doppler with phase-based phenomenon? Well, the sound source is always producing the same frequency, the same sound, the waveform. But what's happening is that the speed at which we are moving through that waveform is increasing, so we are doing some phase scanning, going faster than the normal evolution of time. And this is interesting because it shows us that if we have a control over the speed at which we move through time, through the phase of sound, we change the perception of the frequency, we change the pitch. And this will lead to some interesting approaches to sound synthesis. Let's dive into the role phase plays into sound synthesis, and hold on tight. The most famous FM synth, the Yamaha DX7, is actually not a FM synth, but it's a phase modulation synth. It has been sold as doing frequency modulation because it creates the same harmonic content as it's happening with phase modulation, but the big difference between FM and PM is that FM tends to have pitch drift, especially when you add a continuous current, a DC constant, because, well, adding a constant current to the pitch input, the CV input of an analog oscillator is changing the frequency. So if you are modulating something and then you add DC offset to that modulation, you are changing the pitch. For that reason, doing phase modulation allowed to make a synth that reproduces the same sonic characteristics as FM synth without the pitch drift. And you know what? Operator, the stock plugin from Ableton, is said to be an FM synth. You have different mode. You can do additive, but the basic mode is FMing. You are modulating the first oscillator with the second with the third, and the third with the fourth. Well, you know what? It's also doing a phase modulation. Another thing about phase and its impact when you are modulating things is, listen to this. I'm playing a first pure tone. I'm adding a modulator. You can hear the shift in the timbre, adding harmonics with this modulation, right? What if I were to now change the phase of the modulator? So now we see the impact phase can have to partials, to harmonic content, while used as a modulator. Phase and sound design. We saw phase modulation, like FM synthesis, but actually phase modulation, but there's more. You know the famous Phasor. What is a Phasor? It's changing the phase, right? How are the most old school analog phasors working? Well, they are using notch filters to cut out a very, very tiny portion of the spectrum, but actually shifting the phase. And the amount of poles, if you look at the Phasor, you often see 2, 4, 6 poles. These are actually the amount of notches there will be through the whole audio spectrum. Why use notches? Because the notches have the smallest imprint in terms of change of the tonal balance. They don't touch so many frequencies, yet they alter the phase in a way that is very resembling to a low-cut filter. There is a total flip of phase happening at the corner frequency. Not as strong as is a filter. You don't get the 180 degrees, but there's a flip. Let me show you something. Here's an instance of Pro Q4 with a notch, and here is the phase response. And look, we get at 1.55, so at like more, give or take half of pi, so a quarter of the waveform. So we are at 45 degrees here of shift. this is where the flip happens. If I were to dial in an all-pass filter, you get the exact same curve. I can play with the Q obviously to adjust the shape of things, but you get the same curve except that the all-pass filter gets to, again, give or take, 3.14 radians, so pi, so 180 degrees. The notch, of course, I can adjust the steepness as well and change the curve to make it smaller or larger. And look, what if I would take a phasor? I'm playing here an audio track. And I'm turning on Soundtoys Phase Mistress off. You hear the effect it's applying. Well, here's a little effect rack I created with 3 filters having a notch, and I mapped the frequency of those filters being a bit different to this knob. Let's play that. You hear how we get a similar effect between this and this. It's not exactly the same, but you get the idea. So we are actually modulating the position of different notches through time.